So to better understand how New Hampshire's coast is changing, every 5 years, the state of New Hampshire updates a resource called the New Hampshire Coastal Flood Risk Summary. The science and projections and best practices are always improving, and new issues are emerging, so it's really important that we have this resource updated. The New Hampshire Coastal Flood Risk Summary consists of 2 parts. Part 1, Science, provides a synthesis of the latest trends and projections for coastal flood risk in New Hampshire. And Part 2, Guidance, walks through how you can use that updated science. As you'll hear, flooding comes in different forms here in New Hampshire. Join us as the experts share the science behind these different sources of flooding and share some key findings.
So precipitation is a general term for, all the water that comes down from the atmosphere back to the surface. And so it includes both liquid and frozen forms. And for the coastal report, we were really mostly interested in precipitation as kind of a freshwater contribution to coastal flooding. So there have been several recent climate reports, over the past 10 years, and all of them are indicating that we're gonna overall be wetter in the future in response to climate change. But that is going to come in more intense precipitation events, which of course can be more intense rainfall as well as heavier snowfall with more water content. Rather than having our precipitation kind of spread out, we're gonna see more of that increase come in these bigger events. So what we're really concerned about is the increase in the amount of rainfall produced within a single event. And so there are several ways to define what an extreme precipitation event. We usually describe it based on the amount of liquid water, so it can be snow, it can be rain. For most of our reports, we define it as an event that produces 1 inch or more of liquid water in 24 hours. And then the larger events, which tend to be multi-day events, kind of like the Mother's Day flood, a nor'easter is a good example of these types of events that produce 4 inches of liquid precipitation over the course of 2 or more days. We do expect a change in the distribution of precipitation within the year. Historically, we tend to have a pretty uniform distribution of precipitation, but we're already starting to see increases of precipitation kind of focusing in on the cold season, so the winter to spring season, with little change occurring during the summer and fall. And so in the winter and spring, this could potentially contribute to greater flooding, especially when we have kind of that snow melt added on to spring rain events. Whereas in the summer, the combination of no change in precipitation with higher temperatures leaves the coastal community at risk for drought.
So many times when we talk about sea level rise and climate change, we think about the flooding effects, the storm surge, the waves, all of that, because that's what we can see, and it's very dramatic. But because all of these water systems are connected, the groundwater is also affected by that. It's on a different time scale, it's slower. Groundwater is rising with sea level rise. What we did was we looked at where will groundwater rise in coastal New Hampshire. And then we also looked at where is the groundwater already shallow. And then we identified vulnerable areas.
And groundwater recharge is where you have precipitation or snowfall and snow melt that seeps into the ground and recharges the aquifer. And when we talk about recharging the aquifer, we mean that the water is moving all the way down through the unsaturated soils to that water table. What we're seeing now is that the recharge, there's less in the spring because there's not as much snow melt. There's less in the fall, and there's more in the winter because the ground is not as frozen as it used to be. You get these freeze-thaw cycles. And when you get less recharge in the spring, that means that the summer dry spell is more intense.
We expect recharge to increase in the near term. And then as we move into the latter parts of the century, the increased temperature and evapotranspiration will exceed the increase in aquifer recharge, and we'll actually get a deficit at that point. So as the sea level rises, you don't get as much groundwater discharge to the estuaries. That reduction in groundwater discharge to the estuaries changes the chemistry, the aquatic chemistry.
So high tide flooding is really flooding that's not associated with a storm event. And so we observe it often during the highest tides of a particular year. A lot of folks know it as king tide flooding or sunny day flooding or nuisance flooding, and it's really water that's flowing into a normally dry area when we don't necessarily expect that. Global mean sea level is rising and the rate of acceleration is increasing. The sea level in New Hampshire is rising more quickly than the average global mean sea level. Sea level rise will increase the frequency of high water events that lead to flooding. Right now in Hampton, New Hampshire, we observe about 10 days a month that experience high tide flooding. And in 2050, so in 25 years, we'll see about twice that number of days.
If you've ever been to the coastline during a coastal storm, it doesn't just fill up like a bathtub, right? A bathtub is a flat water surface elevation. I kind of relate it to, like, I can fill up the bathtub at home and I take my kid in and put him in Hurricane Jackson in the tub, and now it's not flat anymore, right? Water's sloshing all over the place. It's coming out at me. And that's what the coastline really is. What this model really does is really brings a physics-based approach to how water moves and reacts. There's really three primary types of coastal storms that we're focused on here. Tropical cyclones, so that's hurricanes. The frequency of those, meaning how many occur, is expected to kind of remain the same, maybe decrease slightly as we go forward in time with changing global conditions. However, the intensity of these, when they do occur, is expected to increase. The second type of storm we look at is extratropical cyclones, which are commonly referred to as nor'easters. They're probably going to remain relatively similar to what we see today. The problem is the sea level is certainly going up. With deeper water, there becomes more energy that can get to the coast. So it's not so much maybe that the storms are changing, but that you have more water in areas mixed with storms that might be the same as we've always seen, but you have deeper water. You can imagine more energy getting places where it hasn't seen it previously. And then the last thing that we're looking at is what we call atmospheric rivers. Those are really long, narrow plumes of concentrated moisture in the atmosphere. Sometimes people call them, rivers in the sky. That's going to be increasing by up to 15%, pushing storm surges higher during higher tides. Even when you don't have necessarily a storm, if you get, higher tides mixed with an atmospheric river, bringing a lot of water up here, that can cause problems.
Yeah, I think what makes this really important is that it's specific to New Hampshire. There's a lot of global projections and national sources of this kind of information, and having the scientists look at what that means for New Hampshire and make it really specific and relevant, and also identify those gaps and those areas of emerging concern. I think that is really a strength of this New Hampshire Coastal Flood Risk Summary.
Good science is so important because it's the foundation of how we deal with changes.